to try to maintain the timing that we define, maybe it's better that we start. First of all, good afternoon, good evening to everybody. Welcome to everybody join this live webinar today. Our topic, first of all, I'm presenting me. I'm Riccardo Savariano, working for Bonfiglioli Consulting as a project leader, mainly on areas of operation excellence and logistics processes. Today we want to talk about one topic that from our point of view is really interesting, and it's talking about intralogistics autonomous mobile robots. When we're talking about intralogistics, we are talking about just want to focus the attention on all the processes and how we can improve these processes inside our plants, like internal logistics, movement handling, and which kind of solution we can use to improve the efficiency and even the effectiveness of our processes. And we want to talk about this, and we want to share with all the participants solution with our partner today that I'm going to present you just in 10 minutes. This is the agenda for today. We have just a brief introduction about Bonfiglioli Consulting for people still doesn't know. And then we are just introduce the framework of lean material flow. Inside this, the presentation will go on with VersaBox company profile presentation, and main focus will be done on the autonomous mobile robots and all the solution for Intralogistics 4.0 in terms of tools, software, hardware, and equipment. Okay. And in the end, we will leave just more or less 10 minutes for questions and answers for all the people that are interested to make some deep dive on the topic that we are going to discuss today. Talking about Bonfiglioli Consulting, we are we born in 1973, so it's more or less 50 years that we work with companies mainly on all the areas of operational excellence, efficiency in processes, and even in the strategy for markets and how we want to improve our processes in internal, but even versus our external markets. How we can do this with 10 offices around the world, with more or less 100 consultants, and we take part even in Accordance Worldwide Network. This is a group of companies, it's more or less 70 companies for working together on all of these topics, providing services to improve and help companies to grow up in markets. For this, the services are mainly focused of value innovations. When we talk about value innovation, we talk about the definition and how we can address the transformation journey for the company, all the services and instruments to address the strategic change for internal and external markets. After that, of course, we have to go inside the company, and when we go inside the company, we're talking about value chain excellence. Value chain excellence is based mainly in improvement of service level to our markets, but even working with along all the value chain to rebalance the cost structure and to improve and optimize all the processes along this value chain. Start with the procurement, planning, operation, production, quality, till the delivery to the final customer. Then we talk about even digitalization. Most of the times here during this year, the 4.0 solution are really make the process better in terms of speed, in terms of precise way to get numbers, to elaborate numbers, and even to help this process to be really, really better. And in this case, even the webinar of today is focused about intralogistics, when we will see that digitalization, all the solution for process digitalization and 4.0 solution will be really important to speed up our changing process. And finally, change management. We cannot do all the activities before without manage the change and review when is possible and when we need, of course, the organizational structure of the company. This is our just main area of intervention that we usually do. But coming back just a while in our topic today, we are talking about intralogistic processes. We used to perform a framework that is this one, that based mainly on lean material flow, because inside all the lean material flow, we can understand better which are the main steps to start to create a material flow that is lean and efficient. And inside this, that's starting from the data gathering, the definition of products and component allocation, which kind of packaging use for each component. After that, we are just inside what we want to discuss today. So how to can make more efficient and more effectiveness the filling cycle and the flows, and even how to optimize our layout, because these are the main point to get all the flows really lean and efficient. How can we do this? Of course, with some 4.0 solution about handling movement of component, finished product, WIP, and material. And using a solution that we are going to present today with our partner, that is VersaBox, we can really realize how to make all of these processes really more efficient, help people working better in more efficient way, and speed up really all the processes when we talk about intralogistics, so internal logistics movement. I just want to introduce briefly our partner today, that is VersaBox, with Jakub Mikalski. Sorry, Jakub, if my pronunciation of your surname is not correct. It is the co-founder.
It's okay.
Okay, perfect. Thank you. Indeed, head of business and product development at VersaBox. And when we talk about VersaBox, we're talking about a smart robotics company specialized in developing solution, technology solution, and implementation of platform based on autonomous robotic units. I don't want to go deeply explain VersaBox, because Jakub, of course, will be more effective and precise than me. So Jakub, I leave the presentation to you. You can share your presentation, solution, and which are the benefits that we can get from using a solution that you're going to present to us today. Thank you.
Thank you, Ricardo. Okay.
I just
I hope that I look similar, like on this picture. Okay. Hello, everybody.
You can share your presentation, Jakub.
Yes, I will do this. Just a second. Okay, do you see the screen?
Yeah.
Okay, that's all. As Ricardo mentioned, VersaBox is a robotic company. Okay, we are more or less software company with the part of the hardware, that is mobile robot. And company has been established in 2013. And at the beginning, we were a small integrator. We provided some automatics for such players like Pratt & Whitney, British American Tobacco, PG. But this is a story. In 2016, we completely changed our business model and focusing 100% on this autonomous mobile transport. But this story is important, and this is why I mentioned about this integration part for history, because we have in DNA industrial processes as well as industrial standards like safety, connections, IT, and so on and so forth. That we really understand how it's work and how the industrial environment looks like and what we can expect from the process point of view, but also from the workers' point of view. Yeah, and this is why our robots are designed and our system is designed exactly like it is. The main pains for in case of intralogistics that you can probably know, that I will go really briefly through it. It's at first lack of workers. This is in our region. Probably in Italy, it's more rather the cost instead of lack of workers. But in Poland and Czech Republic, in our region, is really a problem with the workers. And they start to be costly and costly. And what does it mean? Also, if we use this costly and unavailable workers for such simple tasks like moving with something, pushing with something, okay, some goods within your processes, we log their skills. That means that we are unable to use their hands, brains, eyes. Even the worst worker has the supercomputer in his mind, yeah, in his head. Another one is operational risk. If some heavy equipment is utilized and is operating between the humans, it's pretty risky and a lot of accidents may happen. Efficiency is another solution. If you have no workers, if they are rotating, they are doing some mistakes. There is a lot of companies that the processes are based on the human experience. Okay, that means that if they are retired or they change the job, you lost all of this knowledge. And in case of automatic system, if it's properly designed, it will stay and will be operating even if those experienced people change the job. Of course, there is a lot of reports that's indicated that automatization, robotization is an important part of the growing of the companies, improvement of their efficiency, also saving generation, and so on and so forth. I don't want to talk too much about this, but based on this tendency and based on of these pains, we decided to implement on the market our product that we call Autonomy at Work. And how we think about the intralogistic processes, okay, and automatization of these intralogistic processes. At first, we are thinking that the customers are not looking for just robots, okay? The robots platform is just a part of the process, part of the story. But the customers are looking for, and they need end-to-end solution. I mean, solution that can be, or system that can be fully integrated with the hardware facilities and software facilities that could be managed, that could be properly designed and operating in the way that allows you to achieve your process KPIs, improve the efficiency, and generate the savings. Okay, and this is exactly what we are delivering to the market. Autonomy at Work is a whole package, the end-to-end solution that could be implemented on your process. Portfolio. Right now, we have in our portfolio two mobile platform, VersaBot 500 with the payload out to 500 kilos, and VersaBot 1500 with the payload out to 1.5 ton. Both of this platform, okay, this is a different construction, but exactly the same software that we use for navigation, for autonomy, and also for the process management, fleet management, and so on and so forth. From the beginning, because of our industrial history, we thought about this system as a modular one. That we have the standard platforms, and then we deliver different tools. Some of those tools may be standards from our point of view and could be used relatively easy in different type of processes, for example, like a lifter or a special transportation platform with the where the robot is equipped with the mechanical lock. We are able to dock under this platform, lock it, and to be honest, tow to the destination or exchange empty for full and so on. And also permanent lock that allowed us to connect our platform with some advanced or more complicated automatics like robotic arms or some grippers or whatever, and provide more tailored processes. But this modularity give also another advantages. First of them is the easy and simple after sales or service maintenance processes. If we have the modular structure, we are able to replace relatively easy, whole front with the sensor safety system and so on, or drive units with the drives, gears, and so on, electronics, and the robot can back to the process relatively easy if any problems will happen. Okay, that means that we and our partners, we are able to guarantee the better and faster after sales services, okay, and probably better SLA than others. But modularity means also something different. It's also system that could be tailored relatively easy to the customer's needs. But for example, this is the real case that we already have. This is for tire industry, and the goal was to drive with the big truck tires, okay, twice bigger than the robots as itself, this VB500, but not so heavy that it doesn't make sense to use more costly and bigger VersaBox 1500, okay? But we are able to use the heart of the robot, the main unit, equipped with the electronics, drives, computers, and all of this true autonomy algorithms, and replace fronts and sensors to the tool, and integrated the tool with the robots and have, to be honest, different robots, but based on the same system, okay? It's easiest for us for production, but also for the customers and us for the deployment, because the procedures looks exactly the same, and after sales services. Autonomy at work, our system consists, of course, robots, as I mentioned, okay? They are responsible for the physical part of the process, and the rest is a software. Software responsible for environment mapping, path designing, process design, and process control. The newest part of our system is the virtual factory, and this is the module that's allowed us to build the model of your process, design the process, simulate it, start discussion about the process data, that we work with our partners, with our customers, based on the real data instead of some feelings, how the system may operate. Optimize the system, and finally deliver the optimal solution to the customer. About the virtual factory, I will tell you a little bit more later. But if we have such complementary system that consists robots, autonomy, fleet manager, multi-robotic system, and virtual factory, we are able to implement the whole process and do it relatively easy and fast. Based on the simulation, we are able to design and check the process, check all of these bottlenecks, possible issues, design the process virtually in our lab, and then arrive on site with the final solution. That's allowed us to reduce implementation time. We are also offering different type of financing, and this is also related to the new concept of the Industry 4.0, okay? That the customers are looking for also a new solution for the financing such systems. And we try to be flexible. We are offering the system in CapEx, but also in OpEx that you can rent or lease. And sometimes we are also able to consider some hybrid solution. For example, hardware can be delivered as in the CapEx or OpEx, and server that is responsible for the process can be delivered as a software, as a service, okay? And you can also manage your cost and your budget in a different way. We are located in Poland. That we directly covered our region, Poland, Czech Republic, Slovakia. But right now, we also start to grow outside of our region. We have first partners in Germany, one in French, and of course, big and one of the most important of our partners or dealers, CLS I mentioned from Italy. Main customers that we already have is French Forcia. This is the biggest, our biggest customers, but we also delivered our system to Hutchinson, ABM, or HAF, and to some Polish players like Padmark. This is the big producer for the IKEA. Cisowianka is a producer of bottled water, or Lubella. This is the biggest Polish pasta producer. Okay, that was the first part of my presentation, the brief description, what we are doing, how we are thinking about the intralogistics, and what we would like to deliver to the market and what we deliver to our customers. And right now, I will show you 2 movies, which are the examples of the real operating processes, okay? Just to show you that this is not, just the presentation, and this is not just a beginning of such system on the market. The system is already operating, and I will show you how it looks like. My screen is still visible?
Yes.
Do you see? Okay. Do you see the movie screen?
Yeah.
Okay. This is the Forcia plant in Poland. The system that you see on the screen is already operating there more than 3 years. And we are responsible there for right now for 85, even 90% of the internal transports within the process. This is just the beginning. And in this case, we deliver the production parts from the warehouse to the production nest, welding stations. As you may see, robot is equipped with the lifter dedicated for the palletized load transport, is operating in full autonomy. No induction wires, no magnetic tapes, no mirrors. It's navigate based on the natural environment. It's operating between the humans, between the logistic trains, between different type of trolleys located randomly everywhere in this plant. System is fully certified, okay, that we mark the CE, but it has been confirmed also by the third-party audit. The German company Elocon checked the system according to all of standards that should be kept by such system, and it's fully safe. Okay, and as I said during my presentation, we deliver the whole solution, of course, robots, tool, but also the system is fully integrated with the production. That operator here has a touch screens with our software, our application. He is choosing on the screen what kind of references are needed for the production. This information is sent to the warehouse management system. Then the reach track operator is picking up the proper reference, left on the supermarket, marked on the tablet, the forklift, and then our fleet manager is taking the task and is responsible for delivery to the final destination. I will move a little bit the movie. Oh, this is a good example. We are operating in really narrow corridors together with the logistic trains. We're doing this with the high accuracy. And this plant is like a hell. This is a robotic hell, the huge traffic, a lot of people, a lot of randomly located obstacles. And this is, to be honest, why Forcia decided to use our system, because we are able to present them that our true autonomy, and our autonomy is enough efficient to provide proper efficiency, to keep the proper process KPIs, is able to operate in between the humans, and it's also pretty robust. But that was just the beginning, okay? We started from the transport of palletized loads between the warehouse and the welding stations, as you may see here. Right now, I will stop the movie and show you another one. Because after this first stage of the process, we start to deploy the next step. Okay, right now, you saw how we deliver goods from the warehouse to the production. And now, based on the same platform, but different tool, we provide also the transport of welded frames from the welded stations to the robotic paint shop. Okay, and then painted frames from the paint shop to the assembly line and empty hook bags. And based on this, we covered, as I said, almost 90% of the logistic transport in this plant. There in the background, you may see the first system operating. And what's important, those 2 or even 3 different processes are realized by the same platform, equipped with the different tool, managed by the same fleet manager and multi-robotic system, and fully integrated with the process, okay? That in this case, production lines are equipped with the sensors. We recognize when the whole batch of the frames is ready for the transport. The system is automatically ordering the transport, and we also prioritize the transports. Okay, our system decides from which station the frames should be taken at first in order to prevent blocking of the production. Yeah, because there is not a huge buffer. And the same is in case of paint shop, where we manage where is almost full, and then we are taking at first. It was a huge problem before, because they had to hire a special guy who was taking care from which station those manual workers should take the frames. Otherwise, it was quite often that the production will stop, because on the third or the even second shift, they usually take at first from the first station, the closest one, instead of the farthest. And of course, in this case, this is a tough job. People are not like to do this. It's a huge rotation, and of course, different slots are for different frames, for Porsche, BMW, Skoda, or whatever. Okay, and if you have new workers, then a lot of mistakes may happen. If we deliver the fully automated system, those mistakes disappeared, and this is another advantage for such solution. Okay, here you can see how this accuracy, how high is our accuracy, that we are able to connect those 2 monorails in order to move the system, and that such systems can be integrated with the standard automatics. This dolly has been designed especially for this process, but based on standard Siemens PLC. Our system is exchanging the signal and also the power with this dolly, but such solutions can be designed by all type or integrators. For them, it's a common job. That's the same like in case of robotic arms. This is example how the multi-robotic system is operating. Yeah, the big robot sent information to the main server that, okay, corridor in this area is blocked. This is why this one is waiting. Just while this one docked and confirmed that I'm docked and I will start the process, corridor is free. Then this robot sent information, okay, I will occupy this area. Just when these small robots go through, the big one start his operation once again. Right now in this plant, we have 10 robots, and they are operating 24 hours per day, 7 days per week, and so on. It's pretty good example how such fully automated system could cover the whole intralogistic transport within the production process. But implementation of such solution won't be possible without previous analysis. Ricardo also mentioned this, okay? You can buy the robot, you can put it into the process, and finally you will see that something is wrong. Okay, that the efficiency is lower than you expected. There are some issues that the robot blocks itself, and so on and so forth. And this is extremely important if you think about automatization of intralogistic process. At first, you have to analyze the process, check the bottlenecks, check the efficiency, design the process properly, and then implement it. Otherwise, you may have a lot of problems. Of course, if you order 1 or 2 robots, you can manage this manually or even use some Excel spreadsheet. But if you would like to have the whole fleet, it's impossible. And this is what we implemented to our product. Give me a second. I will open the browser. Do you see my screen? And this is how we work with the customers and how our partners, like for example CLS, may work with the partners or with the customers. Sorry. Okay. We start from analyzing of your process based on your data. We ask you about the layout, about the process data, like action points, of course, and from where to where the goods should be transported. I should change the example. Okay. Something is wrong. Just a second. Oh, action point. It's this one. Just give me a second. I will load the simulation once again. Okay. And this is our virtual factory. This is the cloud-located tool that's allowed us to analyze the process. We are asking customers about data, like a layout in AutoCAD, then about the points where the goods should be delivered and from where. At first, in first iteration, we always ask about how the process should operate in your opinion, how you see the process, in which direction, which corridors may be two-directional, one-directional, so on, which zones are prohibited for the robots, yeah, and then we design the process, how the robots may operating, where they should slow down according to the standards, start to beeping and so on and so forth, which areas are fully prohibited, then we cut it through the virtual zone, okay, and after this, we start the simulation. And this is the simulation of the process, of the same process that you saw on the movies. This is the first process realized by this lifter. 4 robots driving with the goods from the supermarket here and supermarket here and deliver goods to the different destinations. Okay, based on this simulation, we are able to start to analyze the process. Yeah, that for example, which corridors are mostly occupied, where the robots slow down much often, and then where the multi-robotic system is stopping the robots. Okay, in this case, it's invisible, just the 4 robots in the big plant. And after this simulation, we deliver the data. And for these 4 robots, we have the situation that we are able to analyze percentage of time where the robots are charging, percentage of time where the robots are charged but are waiting for the tasks, percentage of time where the robots are stopped by other robots, because they're waiting in the queue, they have to give some space on the crossroads or on the one-way corridors. Then time necessary for precise docking, tool operation is dependent on different type of tool in the process, right empty, right with cargo, and right to either. That means that the robots finish the task, get another task, and is driving to the waiting spots or charging station. And also we analyze some intralogistic data, process data. That, for example, we are taking your historic data or predicted data if it's the greenfield process, implement it into the model, and check for 4 robots how many tasks is waiting in the queue in each time period. Okay. Then we also analyze the buffer occupancy, and can you advise, okay, maybe right now you need 4 robots, but if you add some buffers, maybe 2 or 3 would be necessary enough. Then number of transport by action points, buffer occupancy, and also minimum, maximum, and average time from the ordering the transport and the delivery. Okay, if we know the tax of the production, and we know that, for example, in GL3 production spots, the full process took, for example, 30 minutes or 20 minutes, we see that we are able to deliver on time each transport. Waiting time from order to arrival, and also utilization of the charging stations. And that's also important because localization of the charging stations can improve the efficiency of the process, reduce this percentage of traveling to the idle spots, but also you don't need as much charging station as robots. Yeah, and charging station is also not so cheap element of the process. And we also check the charging parameters of the robots. And that was the beginning of the story, the first movie. First process delivered to the Forcia. Then they ask, okay, but now we would like to transport welded frames from the from the welding station to the paint shop, and then painted frame to the assembly lines. And it started to be much more complicated. The same layout, yeah, but 4 times more spots, and of course, much more robots. The same parameters, corridors, the process has been designed, and we are able to simulate the process. Just give me a second, I will try to make it bigger. Okay. And right now, it's a situation that you are even unable to predict in different way than simulation. Now, there's too much interaction between the robots, production, corridors, and so on and so forth. Based on this data, we are able to check corridors and areas where the robots slow down. It's visible that here is something happened. Here, because this is the departure area, and MRS, in which areas robots are stopped much often by other robots. You see, here is the long queue because the corridor is thinner here, and also because this is the most crowded corridor in the plant. And how the results looks like in this case. See, we have 11 robots. This one are responsible for the frames. We had to increase amount of robots with the lifter, yeah, because if it's more robots, that means that the traffic is higher, and we had to add more robots in order to achieve the KPIs for these lifter processes. But what is important here? In this case, the process can't be realized by such fleet because of the size of the corridors and some other parameters that you saw on the movies. Okay, that after 9 hours, the queue of the task that are waiting has been growing, and within 48 hours, we realized just 95% of the task. Yeah. Then we start to analyze what can be the reason and what can be improved. And we offer, okay, we discussed this with the logistic engineers from the Forcia and process engineer, and we offered some small changes. I would like to say small change, big difference. Sometimes it's not necessary to provide huge revolution in the layout or process. Sometimes, some small change allows you to provide the process much more efficiently. And you can do this based on our partner's experience and the simulator that can give you some evidences that these changes can influence for the process and give you better return of investment, because sometimes you are able to reduce amount of robots or charging stations, but also guarantee that the process can meet your process KPIs. Okay, and we offered some few changes here. Maybe I will. At first, we changed the direction of move. We ask if this corridor can be bidirectional, and we also ask if it's possible to replace entry to the paint shop from this area as far as possible on the left side. Okay, then I start the simulation. The system starts operating, and look, situation looks different, especially here. Here's exactly the same, because this is the 4 robots that are operating from this area. It was even visible on the beginning. Okay, and right now I will show you the results. Of course, we are able to see statistics, real time, action points, occupancy, and battery levels for each robot. Okay, and after this, the same amount of robots, situation is slightly different. We reduced 8% time where the multi-robotic system is stopping the robots. Okay, we keep the same amount of robots and completely change the process. That now, after 9 hours, it's still stable. Some peaks may happen, but these peaks are from the production schedule. Yeah. Here, and of course, we are able to discuss with the customers if this peak can be reduced, or it's not a problem because we still have a time, even if some tasks are waiting in the queue. You know, if we have 30 or 30 minutes to deliver the goods, it might be okay. And other data like buffer occupancy and so on and so forth. And also amount of charging station. As you may see here, in this case, you know, instead of 11 charging station, you can have just 6 or 7, and it's a huge difference in the price. Okay, and the system allows you to operating with any breaks. Okay, this is finish of my presentation. I hope that I was able to present you at first VersaBox, but of course also the idea how we are thinking about the process. Yeah, we deliver not just robots, we deliver you our experience, our simulation tool, and finally optimize and properly designed process that can be implemented. And what I really believe is that this is just one way. Otherwise, you can make a huge mistake, you know, order more robots that you really need. More robots sometimes doesn't mean better flow. You are unable to use Excel spreadsheet for those tasks. You know, it's a headache to try to calculate all of this possible. It's even impossible. Yeah. And if you really think about automatization of the intralogistic process, you should start from the discussion about the process, data analysis, then start discussing about the real data percentage and so on regarding to the process, and then implement such solution. And this is exactly what we and our partners are doing. Thank you. And right now it's time for Michele from CLS. CLS is our dealer and distributor in Italy.
Thank you very much, Jacob. Thank you, Ricardo. Thank you to Bonfiglioli Consulting for this opportunity to present myself and what we do with Intralogistics solutions. Let me show you my screen. Do you see it?
No.
Now you should see it.
Yeah.
Okay. So recently we have signed an agreement with VersaBox, and this is the first opportunity to launch this cooperation together on the Italian market, and not only. Let me start with the presentation of our company. We are CLS is a part of a larger group called Tesia. It's very well known to be the dealer of Caterpillar in Italy, and not only. We have different companies also in Spain and Portugal. CLS is specialized in material handling equipments. It's a company specialized in material handling equipments. So this is the number. Those are the numbers of the group. It's a quite huge group with a turnover of 1.1 billion euros and going to be last year, and it's going to be 1.3 this year, considering all the companies in Europe acting on the European market. CLS is focused on material handling equipment. Historically, he is forklift truck dealer. We have a long story with Hyster, and before with Caterpillar when they were manufacturing forklift trucks. We are also we have extended in the past also our focus on other intralogistic operation, taking care of baling presses and heavy-duty tractors. Since 2019, we have founded the new business unit. I am the head of this business unit. It's called Automation. We are focused on intralogistic automation. We have the agreement with different suppliers, and VersaBox is covering the need of customers and the requirements of a customer in terms of platform and whatever it needs an universal platform to do intralogistics operation. We have 160 mobile workshop on the territory, and we are covering all the territory for any needs. We have also spare parts distribution in 24 hours, so we are really well equipped to follow any issue in terms of product support for our installations. We are what we do. We are using our 6 years experience in a traditional material handling equipment to help the customer building up new workflows in their factories. We are based in Italy, but we are now working also in France, Benelux, and Spain. We are about to open new subsidiaries in those countries. How do we work? So you have seen already VersaBox as a versatile and flexible solution. It's modular, so as you can understand, they respect our principles that are flexibility, modularity, and scalability. Every solution in terms of design, product, installation, and after-sales service are inspired to those principles, because of course we need the customers need to start with installation that are made in a brown field. So now it's always we are lucky if we start on a new production plant on a green field, but usually we work in a brown field where the system has to be integrated. Integration in our view and our vision, it requires those kind of features, and VersaBox, let's say, matches all those principles very well. Flexibility means that the system has to be able to follow the requirements of the customers in terms of operation, peaks, layout changes, shifts. So, and also during the time, the layout of a factory is always changing. So the system has to follow very well and very fast the changing of customers to match the requirement of the market. Modularity means that we have to start with, and you have seen an example in what Jakub showed you before. They started with a workflow which was quite easy, and then they added new workflows, and it's possible to grow very well if you have an idea of where you want to get to in the end of your automation process. It allows gradual investments. Its modular systems are very good to educate the people to think in another way, because your processes are, of course, your strengths, but the new way to move the goods and the parts and your in your factory has to be understood, deeply understood, in order to have new ideas and to change and to make possible the changes that you need to have everything connected together. Scalability, of course, matches the requirement to grow very easily together with the business of the customer, of course. So we have to a VersaBox system is able to start with a small solution, but if you increase the production, you add vehicles, and thanks to the simulation tool, you can increase the fleet of the vehicle very easily. What is important to do, as Jakub mentioned before, is to analyze the processes in terms of goods workflow, but also information workflows. And to do that, you need data. So this is the requirement, the basic requirement to do some automation. We need data to be analyzed and to understand how to deploy a successful system. This is what we call arena. Basically, it's a manufacturing plant. There are three and plus one elements that are the key elements from our point of view. So there is the manufacturing plant, there are buffers or warehouses, and all together job centers. So the production plant is made of job centers. Buffers are connected through material handling system. In this case, we are talking about vehicles that are can connect the areas on a factory to make everything automatic. So this is also the view of the factory of the future, so where everything is automatic in terms of movement and production. See, the customers have been always focusing on the manufacturing production side, and they have reached usually the top, in Italy at least, the top of the automation for the production. But what is now possible to do is to connect all the production together and with the buffers to create a really integrated system. To do that, you need usually, when the system is getting big and you have different workflows that are involved, a workflow control system. So the software that is a layer of software between the machines and your ERP that control the workflow together. and is in our case it's called login. It's a purchase that we have done some months ago just to complete the offer for the customer. So this is what we do, and VersaBox is welcome in our portfolio of product for the next development. So if you have any question, I'm free to answer you. Thank you for your attention.
Thank you, Michele. We are just a little bit in late, I think, because we want to leave to people the possibility to ask if something is could be deep dive, and for if you have some question about what Jacob and Michele presented, please ask, write down on the chat, and we'll be really glad to answer you.
Yeah, I think if somebody would like to ask something, they can use also the mic.
Yeah, maybe I can break the ice. And Jacob, which could be maybe the basic condition to start to implement this kind of solution. I mean, we have to standardize packaging, we have to standardize flows, we have to design which are the basic conditions that maybe could be useful for people they are listening and want to start this process.
Well, I think that at first you have to check how your process looks like now. Okay. Then if you think about the automatization, you have to always think about what is from both sides of this transportation process. Okay. And if you have a transport based on Euro pallets and standard size shape, this is the easiest start. Yeah, because then you can use standard platform, standard lifter. We can discuss about some infrastructure, okay, because they could be on different level and so on and so forth. But this is relatively easy. The next step, you have to think, okay, it should be managed manually, and maybe it's enough for your case, yeah, that the worker on the production, for example, he's leaving some boxes on the pallet is full, just press a button, robots arrive, take it and deliver to the destination. Or it should be fully autonomized in order to avoid some mistakes or whatever. Yeah, then we go deeper into the process. But everything what is based on the standard load, pallets, boxes, and so on, is the best start because it's easier. And then you can think about the next step. The same like I presented in Forcia. Okay, we started with the palletized loads, and they said, okay, it's working, perfect. Let's think how we can automatize the next step, how we can integrate this or change this manual dolly with this monorail system, implement on the robot, and then use it. And finally, the last step is to think how to combine different type of systems, pallets, this mechanical dolly with some automatics, like for example, palletized system. Yeah, then there is no people that are responsible for taking the boxes from the production and put into the pallet. Okay, and combine it as one working solution, even with the autonomous forklifts. Yeah? This is exactly, for example, what Michele showed on one of his slides. Okay, that in the near future, the people will start to think about the complex solution. Okay, automatic warehouse, some packaging or palletized robots or other things. Then transport units, they should be also optimized. It doesn't make sense to use autonomous forklifts if they are driving 80% of the operation time. Then you can use it just to take the pallets from the ground and lift on the stands or on the smallest, faster, and cheapest robots like we deliver. You know.
Okay, thank you, Jacob. If someone else have some other question.
Okay, maybe what I can suggest, if you have any questions, if you have in mind any processes in your organizations that could be autonomized, we would like to check it, please contact with us or with CLS, okay, and then we will respond. And what is also the important message that we would like to share today is that, okay, we are from Poland system, but the system is fully available, maybe fully available in Italy and outside of Poland, and then local partner distributor like CLS is fully prepared to provide you with all of the information about the system and also deploy it, and then after sales services if you decide to use it. Okay, and this is important message because after sales and maintenance is always the one of the key parameter if you think about such solution in your plant.
Okay, guys. I think if we don't have any other questions, I think we can close this meeting. And you have I saw that Isabella just wrote down the contacts just below in the chat. So if you need other information, you can just write to us. Otherwise, thank you for participation. Thank you to Jakub, to Michele.
Thank you.
Thanks a lot.
To see you soon
Us
on some plants.
Thank you.
Thank you, guys.